What is up? I'm hoping you're feeling all right. We are talking about chain rule again. So in our first example, we're asked to find the second derivative. A second derivative just means that we're taking the derivative two times. Okay, so that's the second derivative. So in order to do that, we have to find the first derivative. So let's take the derivative of this, and this is a composite function, so we have to use chain rule. So first, I'm going to take the derivative of the function as a whole. So I'm just looking at the fact that it's some function cubed. Okay, I don't care what the inside is. I'm just looking at the fact that it's something cubed. If I can take the derivative of something cubed, I just do power rule. It's going to be 12, whatever's on the inside, and then I drop down my power. Now I take the derivative of the inside, so I have to take the derivative of x squared minus 5, which is 2x. Alright, so this is my first derivative. Now I'm just going to simplify this a little bit. Whoops. The reason being is I have to use these numbers again. So it makes my life a little easier if it's a little bit simplified. Alright, now let's take the second derivative. Right, and I see that I actually have a product of two functions here, so I have to do product rule and I have to do chain rule. So this is real good practice in doing everything. So remember, product rule, you take the derivative of your first function times your second unchanged, and then vice versa. I'm going to write out a little thing, so if it helps you, then use it. I'm going to define f of x to be 24x. I'm going to define g of x to be x squared minus 5 squared. Okay, and so f prime of x is 24. G prime of x is, well, I gotta do power rule here and chain rule. So I drop the 2 down. So I got x squared minus 5, and now I multiply by the derivative of the inside, which is 2x, right? And for product rule, I can just do the make an x and do the functions across from one another, right? I'm gonna multiply those together. So it's probably bad. I know that f double prime of x is 24x times 2 times x squared minus 5 times 2x plus 24 times x squared minus 5 squared. Right? And this is my second derivative. So doing it this way kind of helps with a lot of the work. It shows your work pretty clearly. It shows you're multiplying f by g prime and g by f prime. So if that helps you, you can write out your work like this. If not, you don't have to. All right, and that is my second derivative right there. All right, let's keep going. All right, now I want to find g prime, given that g is f of 2x cubed. So a little bit weird. The notation is written a little bit weird. It's assumed that I do not know what f is. So f is just some function, all right? So remember, the derivative of f of g of x is f prime of g of x times g prime of x. Okay, that's my rule for chain rule. So I have to take the derivative of the outside first and then worry about the derivative of the inside. Same deal here. So if I want to find g prime of x, I'm going to take the derivative of the outside first, which is f. So it's just the derivative of f. Inside remains unchanged. Multiply. Now I worry about the derivative of the inside, which is 2x cubed. And the derivative of 2x cubed is just 6x squared. And that's it. That's it. There's nothing I can simplify. I don't know what f is, so I'm just going to leave my answer like that. All right, let's keep going. All right, now I got a graph. All right, so it's asking me first to find h prime of 1, and they defined h to be f of x times g of x. All right, so I know I'm going to have to use some values from the graph here. So first of all, let's figure out what h prime of x is. Well, again, this is just product rule, because I'm multiplying two functions together. So I'm just going to write my rule for product rule. All right, so these are multiplying together. And I want to find h prime of 1. So that's going to require f prime of 1 times g of 1 plus f of 1 times g prime of 1. Right? And remember what f prime and g prime are. They're slopes. Oops, that's not a 1. They're slopes. So all I have to do is look at the slope of the line to figure out what that is. Right, so first let's look over here at f prime at 1. So I'm going to assume this is 1 right here. And so I'm asked to figure out the slope right here. Well, it looks like the slope's consistent between this point and this point, between 0 and 2. So I just need to know what the slope of this line here is. So I can count rise over run. 1, 2 to rise, 1 to run. So I know the slope of this line is 2. So I know that f prime at 1 is 2. Then I have to multiply that by g of 1. All right, so g at 1 is 1, 2, 3. It's just 3. So that's just a regular old function evaluation. We're just looking at the graph to get that. Plus f of 1. Well, f of 1 is also just 3 times g prime of 1. So now I'm looking at the derivative of g at 1. So I have this line right here. And I need the slope. It's decreasing, so I know it's negative, and it looks like the slope goes down 1 over 1. So my slope is negative 1. Right? I just have to combine these. So 6 minus 3, which is 3, and that is my answer. All right, let's move along. Now I need to find k prime, where k is defined using quotient rule. So let's write out my quotient rule. K prime of x is, remember, it's the derivative of the top times the bottom unchanged minus the, this is the top times the derivative of the bottom divided by the bottom squared. Right, and I want to plug in 6. So I'm plugging a 6 in for every x value. All right, so I can look at my graph, and again, it's the same process that we just did. So I can look at my graph, and I'm trying to find f prime of 6. Oops, let me put it up a little bit so we can see. All right, I'm trying to find f prime of 6 and g prime of 6, and then the function evaluations at 6. All right, so let's count to 6. 1, 2, 3, 4, 5, 6. I go up. All right, so I'm trying to figure out what the slope of this line is right here. So I know it's negative, and I count, it goes 1, 2 up and 1 over. So I know that I have a slope of 2 over 1, negative 2 over 1. So I know that f prime at 6 is negative 2. And if I look, oh, sorry, this is g. This is g. So I know that the derivative of g at 6 is negative 2. And if I look at f, I know that the slope of f is also going to be negative, and I rise, it looks like 1 and over 2. So I know that f has a slope of negative 1/2, and g has a slope of negative 2. All right, so we can plug those values in, and then at 6, it looks like I have a value of 2 for g and 4 for f. All right, so let's plug those values in. All right, so again, I knew that f prime of 6 has a value of negative 1/2. I have no idea what just happened. All right, f prime of 6 has a value of negative 1/2. And then g of 6 has a value of 2. And then f of 6 has a value of 4. G prime of 6 had a value of negative 2. All that's being divided by g of 6, again, had a value of 2, but that's being squared. Right, we can reduce this a little bit. So I get negative 1 plus 8 over 4. So I should get 7 over 4 as my answer. All right, let's keep going. So now I'm looking at chain rule. All right, so if I want to evaluate p prime of x, the derivative of the outside times the derivative of the inside. All right, and I'm evaluating at 6 again, so I can use the same numbers, which is nice. So let's take a look. Let's take a look. All right, so I'm evaluating at 6. 1, 2, 3, 4, 5, 6. All right, and I want to find, first of all, I need to find f prime of g of x. and then g prime of x. All right, so I need to find what g of 6 is. So I look at my graph, and I know that g of 6 is 2. Right? I know that g of 6 is 2, so that means I need to find f prime of 2. This is 6. All right, I need to find f prime at 2. So I'm going to look at 2. 1, 2. I look up and, oop, what's that called? That is a sharp turn. Right? There's no derivative here. The derivative from the left and the derivative from the right, this is 0, this is like 2. Okay, those are not equal. So the derivative at 2 for f does not exist. Okay, that means that my answer does not exist. And I'm going to go to slightly thicker. Yeah, we go. The answer does not exist because f prime at 2 does not exist. Okay, bad time. All right, let's try g of f of x. Okay, so I need to evaluate g of f of x at 7. So let's look at my graph. Again, what I'm trying to figure out is g prime of f of 7 times f prime of 7. All right, this is what I'm trying to find out. So first, let's figure out f of 7. So 1, 2, 3, 4, 5, 6, 7, and I'm going up to f. So it looks like 1, 2, 3, about 4.5. Right, f of 7 is about 4.5. All right, so now I need to find 4.5. 1, 2, 3, 4.5. And I need to evaluate the derivative of g at that point, which is right here. So I need to figure out what the slope of this line is. So I rise 1, 2. I go over 1, 2, 3. So g prime at 4.5 is 2 over 3. I'm multiplying this by f prime of 7. So again, I go over to 7, and I want to know what's going on with the slope there. So 1, 2, 3, 4, 5, 6, 7. I look up at 7, and it looks like the slope is decreasing by a value of 1/2. So I rise 1 over 2. I can multiply this by negative 1/2. That leaves me with a value of negative 1/3. Right, so my answer for part D is going to be negative, I'm not sure what's happening, is going to be negative 1/3. Right, and that's it for this. I'll see y'all later.